All right, welcome back, people. I had you guys move to the carpet because we're going to do math a little bit different today. I want you guys to be a little bit closer to me and closer to your classmates so you guys can interact with each other. Okay, so before we get started with math today, I need you guys to let me know how you're feeling. I would like you to put a 1 in the air if your morning isn't doing too good today. And that's okay if it is, and we're going to try to move it up. Give me a 2 if you're okay, you're kind of in the middle. Your day isn't so great, but it isn't so bad either. You're going to put a 2 in the air. You're going to put a 3 in the air like Miss Crawley if your morning is just fantastic, okay? And that's okay too. All right, so I see some 1s, I see some 2s, I see some 3s. That's pretty good. That means we're ready to start math. All right, so first things first, all right? What we're going to learn today is going to be a little bit more difficult. But I think you guys are going to get it. I believe in you guys. All right, so here we go. First thing I want to know, just a show of hands. Who knows how to add? Raise your hand. If you know how to add, raise your hand. If you don't know how to add, that is okay. I will not be upset. I just ask that you be honest with me. All right, I would like you to put your hands down. Put your hands up if you know how to subtract. Okay, I got some fairly good amount of you guys know how to subtract. And once again, it's okay if you do not know how to subtract. That is okay. I will not be upset. I just ask that you be honest with me. All right, raise your hand if you know how to multiply. It's a little more difficult as we are just learning that this year. And then lastly, raise your hand if you know how to divide. All right. So, next question I have. Raise your hand if you know what an equivalent equation is. Raise your hand. I don't have many hands up. That's okay. Raise your hand if you know what a non-equivalent equation is. Ooh. All right, so here we go, guys. Today, we are going to learn how to create equations to represent equivalent mathematical relationships. Okay? So I'm just going to put that up here. Of course, we have our objective book, our math objective book. And once again, we're going to go over how to create equations to represent equivalent mathematical relationships. Okay? Now, I know some of these words seem a little bit scary, and some of these words you may not know, and that's okay because I am going to go over them. Okay, so here we go. Equivalent. Equivalent. What does equivalent sound like? What do you guys think equivalent sounds like? Okay, I'm going to go over that as well, what your classmate just said. Equivalent, it sounds like equal. That's absolutely right. When something is equivalent, it is equal. Okay? So if I have an equivalent equation, my equation is equal. Okay? So since we know what equivalent is, anybody want to take a try at what non-equivalent is? Okay, perfect. Yes. Non-equivalent means it's not equal. Okay? That means it's not equal. All right? Your equation is not equal. All right, so here we go. I'm going to put up a problem on the board. And I want to see what you guys come up with. Okay, I'm actually very excited about this. Okay, we all see this equation. We all see this. Okay, so you guys are going to talk to your partners. You guys are going to talk to your partners. I already split you guys up. You already know who your partner is. All right, so you guys are going to turn and talk. And the question that I have for you is this equation equivalent or non-equivalent? Okay, I want you guys to turn and talk for about 15 seconds, all right? And we're going to come back together as a group and we're going to go over it, all right? guys, what do you guys think? Equivalent, non-equivalent? Where we at? Equivalent. I have some people over here, some groups over here, some pairs over here that think the equation is equivalent. And I heard someone back there say non-equivalent. So I like when I have two answers because that means we get to explore both options. All right. All right. So I'm going to call on the first person that touches their nose. All right, here we go. Is this equation equivalent or non-equivalent? Equivalent. Why? How do you know it's equivalent? How do you know that? How do you know this is equivalent? Oh no, we don't know. Boys and girls, we don't know how this is equivalent. That's okay, because we're gonna find out. All right, we're gonna go through some steps to help you guys understand what an equivalent equation is, and what a non-equivalent equation is. We are also going to create our own equations, and I'm very excited about that because you guys get to just use your brains and create these cool mathematical equations, and use your skills that you were learning at the same time. All right, so here we go. We're going to go over this. We are going to take this step by step, okay? So I do ask that you guys keep your ears open. I ask that you keep your eyes on me, okay? All right, so here we go, ladies and gents. So, we're going to go over our steps. So the first thing that we are going to do, all right, before we find out if this equation is equivalent or non-equivalent, we have to go through a few steps, and it's going to help us get to our answer. Okay? So we have 3 steps to go through. Our first step, okay? Our first step. Which operation are we going to use for the first equation? Okay? So our first equation, we're going to always just start with the left equation, okay? Our first equation, we're going to start with our left equation. So the operation, what operation are we going to use for the first equation? This left equation, all right? And when I say operation, are you going to add? Are you going to subtract? Are you going to divide? Are you going to multiply? What are you going to do? Which operation are you doing? So this says 7 plus 1, okay? I know the operation that I'm going to use is going to be addition, okay? And I know that because I see my addition symbol right here, this plus symbol. That means addition. So I know on my first equation on the left, I am going to use addition, okay? So after you find out about your first equation on the left, we find out, hey, we're going to use addition. So now we can see what when we add these two numbers, what that answer is going to be. Okay, so you guys are going to turn and talk to each other. I'm going to give you guys 15 seconds to tell me what 7 plus 1 is. Please talk to your partners. You may go. And once again, ladies and gentlemen, we are solving our first equation, which is the equation on the left. We know the operation that we are using is addition because our symbol tells us so. So 7 plus 1. All right, the first person to scratch their head quickly is going to be the person I call. Okay, here we go. 7 plus 1, what do we have? 8. You guys agree? Okay, I'm going to agree with that as well. So we know that 7 plus 1 is 8. So Miss Crawley, just going to simply draw a little V down here. 7 plus 1 is 8. Just so we know that 7 plus 1 is 8. As we can forget. So we're going to write it down. All right. So here we go. We're going to go to our next step. All right. So our second step. It sounds kind of similar to our first step. Which operation are we going to use for the second equation? Which is the equation on the right side. So the first step, we had to decide which operation we were going to use for the first equation on the left side. Now we have to figure out which operation we were going to use for the second equation, for the second problem. I'm going to give you guys about 5 seconds because you guys are moving pretty quickly. 5 seconds to tell me which operation we're using in this second one. All right, just going to randomly call. Here you go. You can go. All right, subtraction. How do you know subtraction? Oh, you notice the subtraction symbol. You're a genius, man. Yes. So we know that we're going to subtract 6 minus 3, and 6 minus 3, what is that? 6 minus 3 is 3. You're absolutely correct. So I'm going to draw my little V shape. I'm just going to put a 3 here. Okay. So I'm just going to go over this again. We know that 7 plus 1, we know that that's 8. Okay. Now we're going to look on the other side of our equation. 6 minus 3. We know that 6 minus 3 is 3. Okay, I'm going to agree with you guys. All right, so we're going to move on to the next part. All right, so here we go. 8 equals 3. That's what that says. Okay? So we know the value of 7 plus 1 is 8, and we know the value of 6 minus 3 is 3. All right? I would like somebody to raise their hand. I would like you guys to pay attention. Please raise your hand if you believe that 8 can equal 3. Raise your hand if you agree with that 8 can equal 3. Okay, so far nobody thinks that 8 equals 3. I think you guys are correct. 8 cannot equal 3, okay? It's not equal. 8 equals 3. That doesn't make sense. So, this equation is not equal. 7 plus 1 equals 6 minus 3 is a non-equivalent equation, okay? It is a non-equivalent equation. All right, we're going to keep on going. You guys are doing a fantastic job. Please give yourselves a pat on the back. All right, we're going to go through one more example, one more model before we get going. We're going to go through our steps, okay? So let's see. I might be a little tricky. All right. All right, so here we go. Here's this next equation. Yes, I tried to be tricky, folks. Of course I had to. So here we go. We want to know, our big question, is this equation equivalent or non-equivalent? Is this equation equivalent or non-equivalent? Okay. So I'm going to call on someone to tell me, actually we're going to go through the first step together once again before you guys start to do it on your own, okay? I just want to make sure you guys have a clear understanding of what we are doing before you guys go ahead and do it on your own. All right, so we're going to start back with our first step. Which operation are we going to use for the first equation? It's 8 plus 3 for the first problem. Which operation are we going to use? Okay? All right, you may go. Addition. Are you sure it's addition? How do you know? You see the plus, the addition symbol. That's absolutely correct. And ladies and gentlemen, the first person that raises their hand gets the answer to this question. What is 8 plus 3? What is 8 plus 3? I'm hearing a lot of 11s. That's correct. So 8 plus 3 is 11. So we know that. So we know the value of these two numbers. All right. Now, the next step that we do is, which operation are we going to use for the second equation? Okay, so our second equation is on that right side. Our second problem. All right, which operation are we going to use? Yes. You're going to use addition, okay? 10 seconds. Talk to your partner. Please tell me that answer, 7 plus 4. Please tell me what that answer is. Wonder if you guys notice anything. All right, time is up. 7 plus 4. Go ahead in the back. 7 plus 4 is 10. Hey, we're going to try again, okay? 7 plus 4 is 10. Then we're going to revisit again, okay? I'm going to draw some circles here. So if I have 7 circles, 1, 2, 3, 4, 5, 6, 7. I have 7 circles. You see that? Okay, awesome. I'm going to add 4 circles. I'm going to add 4 more. Okay? 1, 2, 3, 4. So if I add all of these circles together, how many will I have? 11. Whoa. Yes, that's absolutely correct. All right, so 7 plus 4 is 11. All right? So I know that 8 plus 3 equals 11, and 7 plus 4 equals 11. So the equation is equivalent. All right? And we know this is equivalent because 11 equals 11. That's equivalent. It's equal. It's the same. All right? So that's how we know our equations are equivalent. All right? I want you guys to put a 1 in the air if you are understanding what we are doing. Please put a 1 in the air. I'm sorry, put a 1 in the air if you're having some issues with understanding what we're doing. Put a 2 if you're kind of getting it, and put a 3 if you're like, this is easy as can be. And it is okay if this is not easy for you. It is okay if this is kind of easy. It's okay if it's super easy. I just want you to be honest so that we can do the best that we can do. All right? And we can reach our objective. All right, here we go. Most of you guys gave me some 2s and 3s, so that's a good thing. All right, we're going to move on. Because now, I'm not going to teach as much. You guys are gonna teach me a little bit before I send you guys off to do some independent work. All right, here we go. This is a trickier one. I'm going to have somebody walk me through this one. All right, who wants to try out the tricky one? First off, we're going to go through this as the problem goes along, actually. All right, so here we go. First, who is my first volunteer? The first person that can rub their stomach. They're going to be the first one. All right, cool. You're my first person. All right, so first things first. Our first step says, which operation are we going to use for our first problem? Which operation are we going to use for this left problem right here? We're going to use addition. Absolutely correct. What is 6 plus 1? 7. All right. I'm going to call on somebody else. Which operation are we going to use for this second problem? Multiplication. That's absolutely correct. How do we know that it's multiplication? The multiplication symbol is right there. What is 3 multiplied by 2? 3 multiplied by 2 is 6. It's absolutely correct. So, our equation reads 7 minus 6. So, is this equation equivalent or non-equivalent? We say non-equivalent. Why did you say non-equivalent? We don't know. All right, so we're going to go through our last step. Okay, here we go. So keep going. I know that, and what's our first equation? 6 plus 1 is 7, and 3 multiplied by 2 equals 6. So the equation is non-equivalent. That's correct. All right, guys. We're just going to go through our last part. And I think you guys will enjoy this. You guys will also be going to Splash Learn to work on your mathematical equations and understanding which equations are equivalent and which ones are not. All right. So it's our last thing before you guys go on your own to enjoy some educational games. All right, so here we go. Can somebody solve this equation? Actually talk to your partners for 10 seconds, and then we're going to go over it. All right, so what is 11 minus 7? 11 minus 7 is 4. Absolutely correct. All right. So, our answer is 4. I want us to have an equivalent equation, okay? So that means whatever our answer is 4. So whatever equation, whatever problem we create on this other side of the equation, it has to equal 4. Okay? So I'm going to throw a little trick out there. I would like you guys to turn to your partners and give me a multiplication equation that will equal 4. All right, you got 10 seconds. All right, I have 2 multiplied by 2. That is 2 multiplied by 2 is also 4. And all right, and I have a 4 multiplied by 1 is also 4. So I'm just going to use 2 multiplied by 2. All right. So does our equation make sense? Is this equivalent? All right, 11 minus 7 is 4. 2 multiplied by 2 is also 4. So we have created an equivalent mathematical relationship. Okay? So, before you guys go off to do your independent work, which is your educational games for today, I just want to go over our objective. All right? We learned how to create equations that represent equivalent mathematical relationships, okay? We know what non-equivalent means. We know what equivalent means, okay? We know how to do our numbers of operation. So please put a 1 if you guys think you struggled extremely with this. Please put a 2 in the air if you think it was kind of okay. And put a 3 if you think this was super easy. All right, you guys are going to break off into your independent work.